Hi there. In this video I will show you how can you connect a device to AWS IoT. So there are like many IoT platforms, cloud IoT platforms in the market. I will be discussing about the AWS IoT platform. So if we take a look at the architecture of how AWS IoT service works, it's like we have the device on the leftmost part where you see the device SDK. That's where our device will be with all the credentials with the program running into it, and this yellow box in between, it's like the entire AWS IoT core infrastructure that's on the cloud. So our device will be able to send the data to AWS cloud through the authorization process, and once the data gets into AWS IoT cloud, there the data will be communicating through the device gateway using MQTT. We will also have device registry and device shadow. There are like a bunch of stuff there. We will look into it one by one. So we have device registry to maintain the number of devices that we will have it stored in the AWS IoT cloud. The rules engine will when the data comes to AWS IoT cloud, if we need to perform certain tasks based on the data that comes into AWS IoT cloud, rules engine will like initialize some kind of a script either within the AWS service like Lambda, or some other external application can be triggered with that. Device shadow is like another AWS IoT service, so that maintains the last known state of the actual device. So if the device goes offline, the device shadow is going to be there, so that the applications that are trying to know the last known state of the device, they can get that state from the device shadow that's stored within the AWS IoT service. And this is how typically the AWS IoT works like. The cloud service that we have, that's what we call AWS IoT core, and there can be devices that keep publishing or subscribe to the AWS IoT core. So it can happen on both ways. There are like a number of development boards that we can use, starting from Arduino, ESP32, Onion, Omega, Raspberry Pi. There are like a bunch of stuff. These are like some of the examples. Now we will be using like ESP32 developer kit. So this kit has like Wi-Fi and Bluetooth inbuilt, and that's what we will make use of for now. So the way the device keeps communicating to the AWS IoT core's MQTT broker is by publishing data. I mean, first thing it needs to do is like connect to the AWS IoT core. Then it will keep publishing data to MQTT broker, so that whatever sensor data the ESP32 is sending goes to AWS IoT core. As well as if it has subscribed to some topic, the device will get the topics it has subscribed to from the AWS IoT core. In order for us to do this, like we need the IP address of the AWS IoT core. So this is what we typically need in a communication, but AWS, instead of giving us an IP address, it gives us like a IoT endpoint host name, which is like alphanumeric long host name that we will use, and the port number for the service running on AWS IoT core is going to be 8883, because 1883 is the default MQTT port number. The MQTT secure, for MQTT secure, the port number is like 8883. So that's what we will be using, the AWS IoT endpoint hostname and the MQTT port number. Okay, the first thing we need to do when we are trying to create a device is like we need to do the device authentication. So we will need to go into AWS IoT core, and there we create a new device first, and we need to save the certificates and keys that will get installed into the the ESP32 device. So let's just like go to AWS. So this is my management console here. I will go to services, Internet of Things IoT core there. And once I'm there, I can go to manage things, and let's say register a thing. I want to create like only one thing for now, so I'll say create a single thing, and let me call this my ESP32. I can create like things of different types so that it can be categorized. So here I have power monitor, that's like one of the types. So if my ESP32 is measuring the voltage and current data, I can put it into that type. So there are going to be like certain parameters that will be inbuilt, but for now I'll not create it. I'll not put this thing into any type. If I want to group, if I want to put the thing into one of the groups, I can do that. The groups can be based on a geographic location or like within certain building. So all those devices within that particular building can be within a group, but I will leave that for now. I'll click next, and I want to download the certificate, so I will click on create certificate. Now this will create like 3 files for me. One is the certificate for the device, so that will be ending with .cert.pem, and a public key for the device and a private key for the device. Let me download this by clicking download. So I will save all the 3 files in one place. Okay, now that I have downloaded these 3 files, I also need to download something called as a root certificate. So when I click on downloading a root certificate, it opens another window for me where I can go and find this RS8 2048-bit key. That's what I need to click, and it will give me a file like this. So I will just like copy this, and I will create a terminal window there, and then I'll say root.cert. I will paste it there, and then I will save it. So I should have a new file called root.cert as well. I don't need this anymore, so I'll close this. I'll also click on activate, so the device gets activated. Then we need to attach a policy. So going back here, so we have created a thing, and then we have saved the certificate and keys. We have also downloaded the Amazon root certificate and saved it in another file. The next thing is like prepare the credentials. So when we want to prepare the credentials, these are the things we will need. We have the device certificate, we have the device private key, we also have the Amazon root certificate. We need to know what's the thing name. So in whatever device name I have given in the AWS IoT core, that's the same name that I need to use. So that was my ESP32, that's the name. So we will just like make note of that. And we also need to know what is the IoT endpoint host name as well as the port number. So if I go here, okay, I haven't I don't have any policy for this yet. So without attaching, I'll add the policy later. I'll just say register thing. So this is created, but a policy has not been attached to it so far. Let me figure out what should be the endpoint name. So here is the endpoint name. This is what we will make use of. This is the IoT endpoint host name, and the port number is like 8883 by default, so we will use that only. Now that we have all this information, let's look into the device authorization. So what is a device authorization? Like we have successfully created the credentials that needs to be there in the ESP32, but now we also need to figure out what is the authorization. Does it have does it have the authorization to connect to AWS IoT core? Does it have the permissions to read, write, as in like subscribe, publish? All these things we will need to configure one by one. The way we give the permissions to a device is by using a policy. So what is a policy? It's like a document that has these two things, version and the statement. So version is like AWS's structure of the policy. So we will make use of whatever latest version AWS has made for defining a policy. And statements are like list of authorizations. One example for the policy structure that goes into the statement is like there needs to be three things: effect, action, and resource. Effect can be allow or deny. Action is like the device can connect to AWS IoT, can publish to it, can subscribe to it, and receive the messages from AWS IoT core to ESP32. So these are the four actions with respect to IoT service that are available in the policy. And the resource is like the actual Amazon resource name that the device that we created should have got allocated. So these are the things we will need. And example policy is this is how it will look like. It's a JSON file, and we will give the version there, and then in the statement, if I want to allow my device to get connected, so IoT connect is like the permission that we give to the resource that we have just created. Okay, now let me go back here, and before I do anything else, let me show you a couple of things that we need to do. So I will open Arduino, and before I do anything else, whenever I connect my ESP32, I just go to ports and make sure that it shows me the port that a new port whenever I connect my ESP32. So that makes sure that the driver is installed. If it doesn't show up in your tools port, then you need to install the drivers. Also make sure that you have selected the board ESP32 development board. The first thing I do is upload the Blink program just to make sure everything is in place. When we use the development board version, the LED built-in is not going to be there as one of the keyword in the board, so I'll just replace this with the number 2, so the inbuilt LED in the ESP32 board will blink. Now I'm uploading it, and one thing to remember is some of the ESP32 boards they don't connect automatically. You need to keep pressing the IO0 or GPIO0 button on the ESP32 when you see that status of connecting. So yeah, I kept pressing the GPIO0 button, and now the uploading is done, and I can see the inbuilt LED on my ESP32 is blinking now. Now let me pull up the template file that I have created for connecting the ESP32 to AWS IoT core. Okay, so this is what I have, and I need to configure all these things now. The first thing I need to configure is the Wi-Fi name so that the ESP32 connects to my Wi-Fi. And here is where I give the endpoint name. So let me go here, copy this and paste it here. So this is, I have put this comment, change this. You need to change all those things. Root certificate, I have copied it from that site already and I pasted it. It's going to be the same for all of us. So I won't bother changing this for now. And this is again something we need to change. The device that I created has the name things my ESP32. Okay, it's my ESP32, so I'll copy this and paste it here. Okay, the Wi-Fi that I want the ESP32 to get connected to is called things school, and the password for that is password. So that's what I will have, and I need to put the device certificate and private key here. So let me go to Finder, wherever I had. Okay, so I'll open this with Notepad. I need to open it with text edit in Mac. If you are on Windows, you can use Notepad for that. I'll open it. Since I have the lines begin certificate and end certificate already, I can choose only the content in between, or copy this entire thing and replace it like this. Okay, so this is my device certificate, and I also need to change the private key now. So let me come here and then open the private key. Open with text edit. And then I will paste it here. Okay, so I have configured all the things that I needed to have changed. So thing name, Wi-Fi credentials, IoT endpoint, the certificates, the port number, I think I have mentioned it already here, 8883, so I don't have to do anything for that. And the topic this device will be publishing to is ESP32 pub, and the device, the topic that this ESP32 will subscribe to is like ESP32 sub. And also a quick walkthrough of the code. So since I have all the variables here, I'm importing that file here. So secrets.h will get all the variables here, and I'm initializing the Wi-Fi client secure so that I can establish a secure connection with the AWS IoT. PubSub is for publishing or subscribing using the MQTT protocol within the ESP32. Arduino JSON is like for me to create JSON packets, so I don't have to like send string data. Instead, I will be making JSON and then I will be like transferring it with the AWS IoT. I'm also including the Wi-Fi library, and then okay, so I'm creating an object called net. That's like the Wi-Fi object that I'm creating. Then I'm also creating another object called client, which is like an MQTT object that is derived from, that uses the Wi-Fi as its as its resource. Then the first function that is going to start is like void setup. So here I have serial begin, so I can see the debug messages, and connect AWS will start this function where I'm initializing the Wi-Fi till this point. So once it gets connected to Wi-Fi, until it gets connected to Wi-Fi, it is going to keep printing dots every half a second. After that's done, the Wi-Fi will configure itself to make use of the certificates that we have provisioned, and then it will try to connect to the MQTT broker at this address with this port number. So once that gets connected, it will print AWS IoT connected. If it doesn't connect, it will print AWS IoT timeout. And also, like as it gets connected, it will also subscribe to this topic, AWS IoT subscribe topic, which is ESP32/sub. Okay, and after the setup is done running, void loop will start running, and then there we have this function called publish message. So in publish message, I have created a JSON document where I have like two things in it. One is like the millis, that's going to give me the time the time of the ESP32 since it has started, and in milliseconds that's what it's going to give me. And then I'm also having like another key in the JSON object called sensor A0 that will keep fetching data from the analog read of GPIO35. Then I'm creating, okay, so this is my JSON document. In order for me to create a character array out of it, so I'm creating a character array called JSON buffer, because I can publish only the character array. I cannot use a JSON document for this function. So here I serialize the JSON to, I convert JSON to a character array, and then I'm going to publish that JSON object into the publish topic. So that the publish topic is like ESP32. So that's what we will have. So I guess you understand what the code is right now. Let me also show you, since I have not configured any policy, the ESP32 device should not be able to even connect to AWS IoT. So it will not show me AWS IoT connected. I have like pressed on upload, so it's compiling. Within a moment it should start connecting, and once I press the IO0 button, it should get connected to the device and the programming should start. Okay, the uploading is done, and let me open the serial monitor. So I have started the serial monitor in like the baud rate 9600, so I'll just like change it here to 9600. It says connecting to Wi-Fi. Okay, Wi-Fi got connected, and then it's printing connecting to AWS IoT, but it's not being able to connect since we have not created a policy in AWS IoT core for it to connect. So I'll go to ESP32 security, and then let me click on this certificate and then click on policies. It says there are no policies attached, so I'll need to create a policy. So let me say attach policy. Okay, I think I first need to create a policy. I'll go to policies, I'll click on create a policy. I'll say my ESP32. Okay, connect, publish and subscribe. So I'm going to allow all sorts of things on this IoT device. I can either do this, or if I want to limit, I can only do IoT publish, comma, IoT subscribe and things like that. But okay, here I'll say my ESP32 policy, and then for simplicity I'll just say I'll give all the rights to it, and the resource name for, okay, there are like two ways of how this works, so let me show it to you. docs.aws.amazon.com/IoT. So in order for us to connect, I need to give the resource name as the ESP32's device name. So this is how it will work. For it to connect, I need to give the resource name as like replace with a client ID. Here I need to say my ESP32 and effect should be allow. Okay, and after that, for me to publish, here I need to give the topic name. the topic with which my device is going to publish is like ESP32/pub. So I'll do this and I'll say allow, add another statement where I'll say IoT subscribe and ESP32 sub. So if you make notice of this, for the device to connect, the resource ARN is going to look like this. So ARN AWS IoT, and this is going to show you the region of the IoT service. I'm currently on the Mumbai region, so it is showing me that it is on AP South 1, and this is my account number, that's what it shows. And then my ESP32 is a client, so I need to give the term client / my ESP32. Whereas for publishing, I need to say, the term we will use is like topic / whatever is the topic name. For subscribe, we will use the term topic filter / whatever is the topic name. If you go to IoT Core documentation as well and then go to developer guide, there in the security section you should be able to find all this information. Let me just show you in security and authorization. If you go there, IoT Core policies, if you go there and then you look at IoT Core policy variables, it will show you that if you want to connect, you use client, if you want to publish, you use topic, and if you want to subscribe, you use topic filter. Okay, now that I'm done creating this, I'll click on create. If you see that it is still not connecting to AWS IoT, it's like keeping on printing dots. Now that I have created the policy, I need to attach it to the device. So I'll go to things, I'll go to my ESP32, click on security, click on the certificate, policies, actions, attach policy, my ESP32 policy, and attach it. Okay, now that the policy is attached, I'll just restart my ESP32. Either way it's going to attempt to connect, but okay, I didn't press the reset button, but it says like AWS IoT connected, which means that the policy that we just created has worked and my device is able to connect to AWS IoT Core. So what should happen now is every once in a second my IoT device or my ESP32 should publish this thing. So if it is publishing it, how can I see it in the AWS IoT Core? I can go to test and then I can subscribe to topic. So if my device is publishing in this is the topic I need to subscribe here. So let me subscribe it. Number of messages to capture, maximum 100, quality of service can be 0, and the data that I am getting is in a JSON format, so it will auto format into JSON. So I'll click on subscribe, and yeah, the data has started coming. So every once in a second I'm keeping on getting data from my ESP32. You can see it from the timestamp as well, like 5, 6, 7, 8, 9. So this is how it works. Okay, and if I want the ESP32 to receive a message from my AWS IoT Core, what I need to do is the first thing, okay, here I have mentioned that whenever the ESP32 gets a message from AWS IoT Core or anybody that has the authorization to send this ESP32 a message, it will use this message handler function. In message handler function, I have commented out everything. I'll just like uncomment this. So what I do here is like whenever a message comes on my serial monitor, it will print incoming whatever is the topic name plus whatever is the payload. Then I'm creating a JSON document and then I'm deserializing it so that the the character array will get converted into a JSON. Once that happens, and then I am accessing the message part of it, and then let me also print message. So this should actually print whatever key, whatever value is there in the key message that gets published from here. Okay, now that I have this, let me upload this. I'll close the serial monitor and then I will upload this. Okay, I'll comment that out so I won't get the topic and payload printed. I should have done serial dot println and then upload this. Once it tries to connect, I'll have to press the GPIO 0 button once again for like a couple of seconds so that I don't get the connecting message anymore. Yeah, and this is uploading. Let me clear this so I get to know once this gets connected, and then connecting to Wi-Fi, connecting to AWS IoT, it should get connected. Okay, and now I should also start receiving messages here. Wonderful. Now this is the topic that my device has subscribed to. Now let me publish some message into that topic. So I change the publish topic, and okay, here it already has a message which says hello from AWS IoT console. If I press publish to topic here in the serial monitor, I should get that message. Or let me just change this a little bit to make sure if my subscribe is working. Incoming serial dot println. Here I will print topic. I'll just do print here upload. When this uploads, like the serial monitor stops working. Okay, I'll press GPIO 0. It's uploading. Once this gets uploaded, okay, so the message has started coming into a ESP32 pub, and when I publish to that topic, I should have received it here. Okay, there is like another policy statement that AWS IoT has, which is called IoT receive. I'm assuming that since I didn't mention that, that's the reason why it is not able to get it. Or let me just go to policies and look at what my policy has. So it says, okay, cool. Let me create another policy. To all, and let's say IoT connect. Here I need to say my ESP32 allow add statement, IoT publish, it send to ESP32 pub, allow, and then IoT subscribe ESP32/sub, allow, add statement, and this device should also receive the messages from the topic ESP32/sub, and allow, and then I'll create this. Okay, now I need to attach all to the thing, so I'll go to things, go here, go to security, go to policies, and then I'll detach this policy, and then I will attach the all policy. Okay, now that I have done it, let me go back to test, and then I will subscribe to ESP32 pub because that's the topic where the device is publishing. Okay, the publishing still works. Now I just need to change this to sub, and then when I publish it, my ESP32 device should have received it, and then it should have printed. Or let me restart my ESP32 and see if it works when I redo this. Connecting to Wi-Fi, and then it should get connected, and once it gets connected I should start receiving the messages here. Okay, I have started receiving the messages, and let me publish it. Okay, so here I am receiving the message. Now let's say hello from Think School, and then I publish it, so I should receive that message here. So we are printing the term incoming and the topic, so that's why it shows incoming and whatever topic it is coming from, and hello from Think School because that's what I published from here. Well, this is what I wanted to show. I hope this is helpful. You can find the link of the drivers and this code, the GitHub link of this code, in the description of this YouTube video. Thanks for watching.